5, 4, 3, 2, 1, ignition, engines full power, and liftoff of Galileo L13. Go SpaceX, go Falcon.
Vehicle is pitching dead range. Stage 1 propulsion is nominal.
These beautiful tracking views, of course, mean that Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral, and the vehicle is throttling down its first stage engines as it prepares for max Q, about 1 minute and 10 seconds into flight.
Power and telemetry nominal.
Confirmation that everything's looking good on board Falcon 9. Now, max Q is a critical ascent.
Falcon 9 is supersonic.
And confirmation that Falcon 9 is moving faster than the speed of sound. Max Q is a critical ascent milestone that we track for every mission because this is the moment in flight with the highest amount of aerodynamic pressure.
Max Q.
And with that confirmation, we have 3 events coming up in quick succession, starting with main engine cutoff, stage separation, and then second engine start 1. Main engine cutoff, or MECO for short, is where all 9 M1D engines on the first stage will shut down in preparation for stage separation, when the first stage separates from the second stage. Stage 2 will then perform second engine start 1, or
shell has started.
SES-1, igniting our single MVAC engine for the first time. MVAC is what Falcon 9 uses to propel the second stage to orbit. After that, we'll also keep an eye open for fairing separation, as we are expecting to see the fairing halves separate a little less than a minute after SES-1.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
So there we have confirmation of main engine cutoff, stage separation, and SES-1. Next up, we're expecting to see and hear confirmation of payload fairing separation. We are attempting to retrieve these fairing halves once they fall back down to Earth using our recovery ship, Doug. And fun fact, this is our 242nd mission to use a previously flown fairing. While we stand by for fairing separation, we do have great views on your screen right here.
Nominal trajectories.
And confirmation of nominal trajectories for both vehicles.
Fairing separation confirmed.
Great view and audio there from Mission Control of fairing separation. Now from here on out, our 2 stages are following different trajectories. As the first stage prepares for its landing attempt on our drone ship, just read the instructions, and the second stage continues taking the Galileo payloads to orbit. Great view of our first stage as it starts making its way back to Earth here. Those grid fins that you can see on the side of the booster are about 4 by 5 feet. Just for reference, that's about the size of an average coffee table. Now, as you can see on the right-hand side of your screen, Falcon 9's second stage is making its way to orbit, roughly at an altitude of 140 kilometers, traveling more than 11,000 kilometers per hour. Telemetry is a crucial aspect of any space mission, providing mission control with real-time data about the health and status of the rocket and its systems. For those of you watching along at home, you'll notice some important telemetry data is always displayed on your screen throughout a launch. On the bottom left, you can see the speed and altitude of the first stage. This data shows the first stage elevation and how fast the stage is traveling as it makes its way back to Earth. We are coming up also on 2 engine burns that will be used to help slow the booster down as it attempts to land on our drone ship, which tonight is Just Read the Instructions, currently stationed downrange from the launch site in the Atlantic Ocean. And then on the bottom right-hand corner of your screen, you can see the speed and altitude of the second stage as it continues to take our Galileo spacecraft to orbit. We are just over 5.5 minutes into today's mission, and in case you're just joining us, we did have an on-time liftoff tonight at 6:40 p.m. Eastern from Cape Canaveral Space Force Station in Florida, followed by successful main engine cutoff, stage separation, and second engine start 1. Quick correction there, sorry, 6:50 Eastern liftoff. And now we are standing by for our first stage reentry and landing.
Nominal trajectories.
And confirmation that both vehicles are still on nominal trajectories. To start the upcoming entry burn, we'll relight 3 of the M1D engines on board the first stage.
Stage 1 entry burn startup.
Right on schedule.
Stage 1 FTSO safed.
We need to do this entry burn to help slow the vehicle down as it passes back into the Earth's atmosphere to reduce reentry forces. That will help us, in turn, recover and reuse this booster on future flights. During this re-entry burn, Falcon 9 is...
Stage 1 entry burn shutdown.
There's confirmation of entry burn shutdown. So while we've decelerated some by firing those Merlin engines, we're still moving really fast. That causes the rocket to fly through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle's surface. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little bit more on the outside of the rocket. As I mentioned earlier, you can continue to track the first stage telemetry in the bottom
terminal guidance.
left-hand corner of your screen. As the booster continues to make its way to our drone ship, just read the instructions. Reusability is key to lowering the cost of spaceflight, which enables more investment in critical space infrastructure. The Falcon 9 first stage supporting today's mission has now performed its entry burn for the 22nd time.
Stage 1 transonic.
Confirmation that
Stage 2 FTSO safed.
booster is transonic. And right now we are standing by for landing burn start on board the first stage in just about 10 seconds.
Stage 1 landing burn.
Confirmation of landing burn startup.
Landing leg deploy. Stage 1 landing confirmed.
And confirmation of first stage landing. This was the 22nd launch and landing for this first stage. This landing marks SpaceX's 349th recovery of an orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy, and confirmation of nominal orbital insertion by our second stage. Now, with those confirmations, we are going to bring today's webcast to a close.